the tomato farming industry is one of the largest and most valuable agricultural sectors globally. From open field farms in North America to cutting-edge greenhouses in Europe, the demand for fresh, high-quality tomatoes continues to soar. However, the process of harvesting and packing tomatoes still heavily relies on manual labor, which is increasingly scarce, unreliable, and costly. Faced with this challenge, researchers and tech companies have been tirelessly seeking solutions to automate this process. Now, let's dive in and explore together. At Wageningen University in the Netherlands, researchers have developed a prototype for an automated tomato harvesting robot designed for greenhouse environments. This system features flexible robotic arms, supported by high-resolution 3D cameras and spectral sensors, enabling precise detection of ripe tomatoes hidden within dense foliage. Notably, the robot is equipped with deep learning AI capable of distinguishing between tomato varieties, identifying diseased fruit, or those not yet fully ripened. Additionally, the robot can adjust its grip strength, arm movement speed, and approach angle to ensure the fruit's skin remains undamaged. Moreover, each harvest is a learning opportunity. Data is recorded and analyzed to refine the control algorithms, making the robot increasingly accurate and responsive over time. Programmed for precision and seamless operation, the robot navigates along rows of plants using a self-propelled wheel system equipped with collision avoidance sensors. AI-powered cameras scan each plant, signaling when ripe tomatoes are detected. The robotic arm then gently approaches, detaching the fruit from the stem with a twisting motion that mimics human movement. The harvested tomatoes are carefully placed into cushioned trays designed to minimize damage during transport. Some advanced systems even incorporate surface temperature sensors to identify sun-damaged or internally spoiled fruit that might escape the naked eye. With specialized LED lighting tailored to specific spectral ranges, the robot operates efficiently at night or in low-light conditions. On average, a modern robot can harvest between 20 and 35 tons of tomatoes per hour, far surpassing manual labor and unaffected by weather or work hour limitations. 1. Immediately after harvesting, the tomatoes are transported via a smart conveyor system to a central processing area. There, robots inspect each tomato using multispectral cameras paired with artificial intelligence, evaluating quality based on criteria such as color uniformity, firmness, surface shape, and size. Tomatoes meeting the standards are sorted by robots into trays arranged in an optimized geometric structure, minimizing wasted space and preventing collisions during transport. Advanced packing robots can also perform layer stacking, ensuring even weight distribution within each box to maintain freshness longer and reduce the risk of bruising during long-distance shipping. Additionally, each tray is equipped with a QR code or RFID tag recording details like production batch, harvest date, greenhouse location, and even the type of fertilizer used. This is crucial for ensuring quality, managing risks, and meeting international food safety standards. It's clear that the introduction of robots in tomato farming and packing is not only a technological revolution but also addresses long-standing challenges in modern agriculture, such as reducing reliance on manual labor, increasing precision and consistency, and optimizing productivity, among others. Of course, for these robots to achieve widespread commercial adoption, several hurdles remain. The initial investment costs are still high, requiring support from governments or modern cooperative models. Additionally, robots are still being refined to better handle complex scenarios outside greenhouses, such as rain, wind, uneven terrain, or asymmetrical plant canopies. Nevertheless, with the rapid advancements in robotics, artificial intelligence, and next-generation sensors, the vision of every tomato farm being equipped with a fleet of professional robot workers is no longer far-fetched. This marks a pivotal turning point, ushering global agriculture into a new era, an era of automated, precise, and sustainable farming. Did you know that the secret ingredient behind the rich, irresistible flavor of your favorite cold beer is a flower? That's right, hops. A small flower with a powerful role, the very soul of the global beer industry. But here's the surprising part. In many countries, hops are sparking an agricultural revolution, where farmers aren't just preserving an old tradition, but earning billions of VND each year from this humble plant. So, what exactly makes hops the green gold of modern agriculture? All will be revealed in today's video. Hops belong to the Cannabaceae family, closely related to cannabis and hemp. But don't panic. Hops contain no psychoactive substances. Instead, they're a key ingredient in beer production, one of the most widely consumed beverages worldwide. Each tiny dried hop cone is packed with lupulin resin, which gives beer its distinct flavor, bitterness, aroma, and even helps preserve it. What's more, different hop varieties give beer unique personalities, a trait especially prized in the craft beer world. That's why hops have become a premium agricultural commodity, with their market value skyrocketing over the past decade. Historically, hops were mainly grown in parts of Europe like Germany and England. But since the craft beer boom began in the early 2010s, demand for hops has exploded globally. According to the Brewers Association, the U.S. alone had over 9,500 active breweries by 2024, with most prioritizing fresh, high-quality, locally grown hops. As a result, hop farms in Oregon, Washington, and Idaho have become gold mines for farmers. Hops aren't something you can grow casually or harvest on a whim. This is a high-maintenance crop that requires advanced techniques, strategic investments, and specialized knowledge to ensure both quality and commercial value. Depending on local climate and production goals, farmers select the most suitable hop varieties. They then build towering trellis systems, 6 to 8 meters high. Because hops grow vertically and can reach up to 10 meters, this is both a technical challenge and a considerable cost in materials and labor. Next comes the irrigation system, often using drip methods paired with organic fertilizers, to ensure nutrient-rich soil without waste or pollution. Throughout the growing season, especially during the blooming phase, growers must closely monitor humidity, temperature, and pest control. Hops are particularly vulnerable to fungus and aphids, fierce enemies that can devastate an entire crop if left unchecked. Around August to September, when lupulin levels are at their peak, hops are harvested, either by hand or with specialized machines. They are then immediately processed and dried at low temperatures. This is a critical stage, because drying hops too hot or too long can evaporate up to 70% of their aroma oils and lupulin, destroying both their flavor and market value. Once dried, hops are either compressed into pellets or stored whole, ready for brewing. In beer production, hops are added in multiple stages, early on for bitterness, then later for aroma. After boiling, the beer mixture is fermented using yeast, which converts sugars into alcohol and CO2, then it's filtered, bottled, and distributed. The presence of hops throughout this process is what creates the vast diversity in beer flavors. And that's why hops aren't just a crop, they're a catalyst for a multi-billion-dollar beer industry, and a sustainable income source for thousands of farmers worldwide. In some regions, farmers earn up to $10 million annually from hops alone. Beyond beer, hops are now finding value in cosmetics, supplements, herbal medicine, and even organic livestock feed. The hop market is expanding fast, and its worth is no longer tied solely to traditional beer making.
When it comes to AI, you might imagine it in labs, high-tech hubs, or even in sci-fi movies. But in India, AI is working right in the fields. From soil moisture sensors to drones and harvesting robots, AI is becoming a powerful companion on agricultural farms. Let's explore how Indian farmers are doing it. India is a country with a long history of agricultural development, with nearly 60% of the population dependent on agriculture. However, despite its rich traditions, the agricultural sector here is facing many major challenges. Low productivity, climate change, dwindling natural resources, and pest problems are the top concerns. Therefore, the application of artificial intelligence, AI, in agriculture is not just an option, but has become an extremely necessary solution. AI not only helps solve these pressing problems, but also opens up huge opportunities for the Indian agriculture sector. And you know what? AI is really changing the game. One of the big questions in agriculture is how to save water when India is always in a state of scarcity. Can you imagine farmers worrying about when their crops need water, and if they overwater, the water will be wasted? Don't worry, AI has the solution. With the help of soil moisture sensors and AI-based weather forecasts, these irrigation systems can determine the exact time and amount of water for the crops. No more random watering. Instead, watering according to a plan, saving water and ensuring that crops receive the amount of water they need without wasting it. In addition, AI also helps farmers optimize fertilization and crop care through smart applications. These applications collect data from various sources such as weather, soil moisture, and soil testing, then provide personalized farming recommendations. This not only increases productivity by up to 60%, but also reduces costs by up to 20%. AI can even detect problems in irrigation systems such as water leaks, helping farmers repair them in time and stop wasting precious resources. Analyzing the nutrient composition of soil is a time-consuming and laborious task. But don't worry, AI will help diagnose the health of the soil like a specialist doctor. Current AI technologies can monitor the entire growth process of crops, from sowing to harvesting. This system helps analyze the health of crops through parameters such as soil moisture, pH, temperature, and the amount of nutrients needed. This information is sent back to farmers, helping them make timely farming decisions. Another prominent application of AI is the ability to detect diseases and pests on crops early. Artificial intelligence can identify signs of disease through images taken from sensors or drones. For example, AI can detect pests like fruit flies or beetles at an early stage, allowing farmers to act quickly. In addition, high-tech machines like automated planters and harvesting robots are becoming more common on large farms. They use AI to locate crops, analyze fruit size and ripeness, and then decide the most accurate time to harvest. This not only saves farmers time, but also reduces the risk of crop failure due to harvesting too early or too late. AI-equipped drones are also an effective solution for spraying pesticides and fertilizers automatically. This technology not only reduces the amount of pesticides used, but also helps farmers save time and effort while protecting the health of workers. Artificial intelligence is not only helping in resource management, but also helping farmers predict crops and plan production more efficiently. Using sensors, drones, and real-time data, AI helps in analyzing soil fertility, forecasting climate, and making precise farming plans, thereby helping farmers manage crops better and optimize production. Thanks to AI, Indian farmers are not only becoming more efficient, but also reducing production costs. There are over 450 agritech startups in India developing AI solutions, and these technologies are helping over 14 million farmers manage their crops smarter. Without favorable natural resources for agricultural development, Israel is the only country capable of turning deserts into arable land, growing crops, and raising livestock, even changing the world's agriculture. So, what has turned a country full of deserts into the most modern agricultural granary in the world? It is even likened to the world's Silicon Valley in the agricultural sector. So, today, let's explore agricultural production activities in Israel to see how the agricultural economy in this region has developed. Israel is a small country with an area of over 20,000 kilometers squared, of which desert accounts for 70% of the territory. The rest are bare rocky hills with an extremely harsh climate. This area is inherently unsuitable for farming and raising livestock. But now, the whole world is surprised because Israel has created a miracle to turn the yellow sands of the desert into a green color full of life. So, what measures have the people of Israel adopted to transform their agricultural economy and compete with other agricultural powers? Israel is a small country with an area of over 20,000 kilometers squared, of which desert accounts for 70% of the territory. The rest are bare rocky hills with an extremely harsh climate. This area is inherently unsuitable for farming and raising livestock. But now, the whole world is surprised because Israel has created a miracle to turn the yellow sands of the desert into a green color full of life. So, what measures have the people of Israel adopted to transform their agricultural economy and compete with other agricultural powers? In fact, Israel has taken advantage of mountainous areas and harsh climates to develop power plants from solar energy, which is a clean and eternal source of energy. These energy sources are applied in life and agricultural production. Therefore, a lot of other resources such as water are saved. The water sources in the desert in Israel are only used for growing plants. The most popular crop grown in the Israeli desert is the cherry tomato, which is exported to many other parts of the world. Today, Israeli farmers are also developing newer varieties of tomatoes to increase yields. In addition to tomatoes, you will be amazed by the olive groves, vegetables, and many other crops that are adapted to the desert conditions. In the Judean desert region just north of the Dead Sea, agriculture is even more advanced. Farmers use the minerals found in the soil and sand to train crops to grow vigorously. The crops that are exported to many countries and considered to be the best in the world are onions and basil. To develop a strong agricultural sector, Israel invests more in agriculture than any other region in the world. Each year, the country invests nearly $100 million in agricultural research, accounting for about 3% of the country's total agricultural output. Scientists at the centers not only study drought resistance in plants, but also create new varieties of vegetables and crops with high yields, as well as biological control methods and pest control that use less chemicals. According to statistics, with only 2.5% of Israel's population working in agriculture, the country exports about $3.5 billion worth of agricultural products each year and is one of the world's leading agricultural exporters. In the Judean desert region just north of the Dead Sea, agriculture is even more advanced. Farmers use the minerals found in the soil and sand to train crops to grow vigorously. The crops that are exported to many countries and considered to be the best in the world are onions and basil. To develop a strong agricultural sector, Israel invests more in agriculture than any other region in the world. Each year, the country invests nearly $100 million in agricultural research, accounting for about 3% of the country's total agricultural output. Scientists at the centers not only study drought resistance in plants, but also create new varieties of vegetables and crops with high yields, as well as biological control methods and pest control that use less chemicals. According to statistics, with only 2.5% of Israel's population working in agriculture, the country exports about $3.5 billion worth of agricultural products each year and is one of the world's leading agricultural exporters.